All right, in this lesson, we are going to be talking about how to solve a quadratic equation by completing the square. A really big part of this assignment, or of this section of notes, involves us solving using square roots, which is the video that you were supposed to watch before this video. So if you didn't watch this video, please pause, go back, watch the other video first, do those practice problems, because these are really directly tied together. So, our essential question, how do we complete the square, which we're going to use the abbreviation CTS for, and how do we use that to solve a quadratic equation? And we're really going to look at those two pieces separately. I'm going to focus for the first half of this video on how do you actually complete the square? What does that mean? Why is it called that? And then after we've done that, why does that help us, or how can we use that to solve a quadratic equation? So what you saw in the last section of notes is that you could solve a quadratic of the form x squared equals 16 simply by square rooting both sides, and that would give you that x is 4 and negative 4. Well, that's really nice because you can evenly square root both of those sides of the equation. However, not every problem is set up so that you can use that perfect square root method. For example, if you look down here at x squared plus 6x, I could not square root, if there was an equal sign, I could not square root both sides of that equation because I would not possibly know how to square root x squared plus 6x. I wouldn't know what to do with this plus 6x. So the lesson today is going to say, how can we manipulate something like x squared plus 6x so that we could ultimately turn it into something squared? That's really our goal, is to say, how can we take an expression that is not a perfect square and turn it into something that is a perfect square? There is a great video that you can watch on YouTube that gives you a visual understanding of what we're going to do. I'm going to just focus on the algebraic understanding, but a lot of people are really visual, and that video might help you understand in a visual way our goal. So feel free to check that out using that link. Okay, so our ultimate goal is to get x squared plus 6x to be something quantity squared. So we're going to temporarily pretend that rules of equations don't matter because I really just want to focus on the how, mathematically, how we do this. So if I had some number here in this box that made this factor to perfectly be a square, that would make my life easier. So we're going to figure out how we get that number. Okay, so if we set up the box as if we were going to factor, x squared would go on the inside. These two diagonals would add to be 6x. We know that x squared is made from multiplying x times x. And what I'm saying is I want these two diagonal boxes to be exactly the same and to add to be 6x. So thinking of something that is the same number twice that adds to be 6, well, that's going to be 3x and 3x, which would make this plus 3 and this plus 3, which would give us the number 9. So if I had plus 9 here, I want you to think now about if we were actually going to factor that. If this originally said x squared plus 6x plus 9, you could either make the box, if that's your preferred method, or you could use the parentheses method. What makes x squared? X times x. What makes 9? 3 and 3, and then we can check 3x and 3x does give us 6x, which is what we were going for. The beautiful thing about this is we just said that this factors to be x plus 3, which means we could now rewrite this as x plus 3 quantity squared. And the purpose of doing that is that we are then able to, if this was an equation, square root both sides and go through that process of how we solved in the 10.5 video. So the process that we're going to use each time is that same thought process. How could I add a value that would make this something that factored to be the same set of parentheses or the same factor twice? And there is a shortcut, a little tool that you can use to help you figure out what that value is that you would need to add to both sides. And that shortcut is right down here. What it is it says that you're going to take half of your b value, which if you remember from earlier in this chapter is always the number that's in front of just x. You're going to take half of your b value and you're going to square it. That's the number that you're going to add to both sides. So if you think about that, on this case, b was 6. So we would take half of 6, which is 3, and we would square that, which is 9. I want you to notice that the 3 actually comes into play in this spot as well. That's what's going to be inside parentheses. So when we are talking about equations, one big thing I'm going to remind you about, and I'll remind you again when we actually get to problems with equations, is that if you do something on one side of the equation, you're going to have to do it on the other side of the equation. So let's look through some examples where there is not yet an equation, examples just like the one in this box on the left, to find the specific value that would give us a complete square, and then to factor it. Okay, looking at example 1, in order to figure out what value we would add to complete the square, we need to take half of b and square it. So here, b is 2. We're going to take half of 2 and square it. Half of 2 is 1, and 1 squared is still just 1. So the value that we would add, or that we would put in the c spot, if we were talking about a, b, and c being our constant, is 1. Then if we factored this, x squared plus 2x plus 1, we would get x plus 1 times x plus 1, or x plus 1 squared. You don't actually ever have to go through the process of factoring. It's always going to work out to be this number inside parentheses as your value inside with x. You can factor it. If you get stuck or you don't know what you're doing, go back to the value you just added and make your box, or use your 2 sets of parentheses and factor it. Remember, you're looking to make the same set of parentheses twice. So if we look at number 2, just because there's a y doesn't mean we're not doing the same thing. The b value that we're looking for, so we're trying to figure out what number we could put inside this box that would make this polynomial become y minus something squared. I know it's going to be a minus because it's a minus right here in the original problem. So what is b? b is negative 8. So I'm going to take half of negative 8 and I'm going to square it. Half of negative 8 is negative 4. That's what's going to go here. That's why it's y minus 4. If I square it, that's going to give me 16. That's the number that's going to go here. So the number that I would add to both sides to make this a perfect square, which we're going to get to on example 4, would be 16. The factored polynomial would be y minus 4, quantity squared. All right, we're going to do one more like this. Notice this is in the wrong order. It's in the wrong order solely to try and mess you up, because that's what mean standardized tests like to do. So I'm going to rewrite it as x squared plus 9x. My ultimate goal is to get x and something squared. So let's look at b. Here, b is 9. Half of 9 is 9 over 2. That's what's going to go in here. And yes, it's a fraction, and yes, it's scary, and we don't like fractions, and you could turn it into 4.5 if you want. I would rather not, and I think I see why. Here's what this is going to factor to be. It's going to factor to be that if I add something on both sides, and that something is going to be what I get when I square 9 over 2. Remember, from rules of exponents, you're going to shower the power. So that is going to be 9 squared, which is 81, over 2 squared, which is 4. So we would add 81 over 4 to both sides of the equation. So we would add 81 over 4, and our new factored polynomial, our perfect square, would be x plus 9 over 2 squared. Okay, moving on to solving. Now we have equal signs. So if you think back to the first 2 sections, our ultimate goal is to get in set notation whatever x values are going to make this true. And actually, if you look at some of these problems could be solved by factoring. So you could, in theory, use that method. But since we're focusing on complete the square, that's what we're going to work on right now. So one of the things about complete the square is we always want this other number that's not our c, or the number that is our c value, to be on the right-hand side of the equation when we are solving. So I'm asking myself, x squared plus 16x plus some number that I haven't figured out yet is going to equal negative 15 plus that number that I need to figure out. So in order to figure out what goes inside that box, I need to do the process that we just did on 1 through 3. So remember when I talked about you have to add, if you're going to add something to the problem, you have to add it on both sides of the equation. That's where it's coming in. We're talking about an equal sign now. So we need to identify our b. Here, b is 16. That's the number in front of x. I'm going to take b over 2 and square it. If I take b over 2, I get 8. That's going to be the number inside parentheses with x plus 8 quantity squared. If I square it, I'm going to get 64, and that's going to be the number that I'm going to add to both sides of the equation. So x squared plus 16x plus 64, that factors to be x plus 8 quantity squared. If I factor that, I get x plus 8 times x plus 8. I'm going to combine like terms on the right-hand side, negative 15 plus 64, and that's going to give me 49. Now, this problem should look just like the problems in the last section, where we could now square root both sides, because on the left, I just have something squared. On the right, I just have a constant. So what I can do now is I can square root both sides of this equation. Now remember, if we square root 49, we are creating a square root. There are two possible things that I could square root 49 and get. I could get positive 7 and I could get negative 7. So from this point, I'm going to create two separate equations. I'm going to create an equation where x plus 8 equals 7. I'm also going to create an equation where x plus 8 equals negative 7. And again, you can go back and watch the video on the section before this with solving using square roots, because we're applying that right now. Now to solve for x, I'm going to subtract 8 on both sides. Here that's going to give me negative 1. Here that's going to give me negative 15 if I subtract 8 on both sides. And our final answer should be in set notation with the smaller number, comma, the bigger number, using those little squiggle brackets. So let's recap what we did. We figured out what value we needed to add to both sides to get our perfect square. We factored the left-hand side now to be that perfect square. Then we had a perfect square equals a constant. We square rooted both sides. We set up two different equations and we solved each of those equations. So we're going to go ahead and start number 5 now, and I'm going to erase this part that's coming over here. So for number 5, the constant is not on the other side. So the very first thing I'm going to do is I'm actually going to add 6 to both sides so that 6 is over on the right-hand side of the equal sign, just like it was on number 4. Now, I need to figure out what number is going to be added to both sides to complete the square on the left, to fill in the box on the left. So I need to take b, which in this case is negative 4. I need to take half of negative 4, and I need to square it. Half of negative 4 is negative 2. Negative 2 squared is positive 4. So the number that needs to be added on both sides is positive 4. On the right-hand side of the equal sign, we're going to have 10 now. On the left-hand side, we're going to have something squared. And the something we're going to have is x, and the number that was down here, minus 2. Because x minus 2 times x minus 2 is x squared minus 4x plus 4. So now we're exactly where we want to be. We're in a problem like last section where I have something squared equals a number. We can square root both sides. That's going to give me x minus 2 equals, now 10 does not evenly square root. It's not a nice number like number 49. My 5th period class would say that this is a dirty number, 10, because it doesn't evenly square root. So what I'm going to do is actually, I'm just going to write that as plus minus, that's a plus over a minus symbol, the square root of 10. The square root of 10 is a number, I just don't know what that number is. To isolate Our variable now, we need to add 2 to both sides. And since 2 is not actually inside a square root, all that's going to happen is that I'm going to write it in front of that plus minus. So our final answer is going to be 2 plus or minus the square root of 10. You could also write that as 2 minus the square root of 10, 2 plus the square root of 10, if you wanted to write it that way. All right, I'm going to do 3 more examples. I'm going to try and go a little bit more quickly. But remember, you can always pause this video, rewind this video, watch it again. So I'm going to rewrite this, and I'm going to leave space for the number I need to add to both sides. So here, b is positive 10. So b over 2 is going to be 10 over 2 squared, which is 5 squared, which is 25. So the number that I'm going to add on both sides is 25. I'm sorry, that is sloppy. The left-hand side is going to factor. It's always going to factor to be something squared. In this case, that something is x minus 5. And remember that 5 comes from the step before I square it. X plus 5 quantity squared equals, and now I'm adding negative 9 to 25. That's going to give me positive 16. Now we're back to a problem from yesterday or last class, whenever you watch that video. We're going to square root both sides. That's going to give me x plus 5 equals 4, and x plus 5 equals negative 4. There are 2 numbers that we can square to get 16, positive 4 and negative 4. If I solve here, subtract 5 from both sides, I get negative 1. And on the bottom, subtract 5 from both sides, I get negative 9. So my final answer, negative 9 is smaller, negative 9, negative 4. Now, if you're feeling like you have a good understanding of this, I would recommend that you pause this video and you see if you can work through number 7 on your own. Number 8, I'm going to give you a tip for the first step before you try and do that one on your own. But I'm going to work through this right now with you. Okay, x squared plus 9x plus something is going to equal 1 plus something. So I want to figure out what's going to go inside that box so that I can add that number to both sides and have a perfect square on the left. This is actually straight from the problem that we did on number 3, but I'm going to redo the work quickly down here anyways. B is 9, so b over 2 squared is 9 over 2 squared. So inside, I'm going to have x plus 9 over 2. And we said that 9 over 2 squared is 81 over 4. Shower the power, multiply or square 9 and square 2. So I'm going to have 81 over 4 in each of those boxes. In order to combine 1 plus 81 over 4, I need a common denominator. Well, 1 is the same thing as writing any number over itself. So I could rewrite 1 as 4 over 4, which now means I have 2 things that have exactly the same denominator, which means I can add the numerators, which would give me 85 over 4. Now, just like I wanted, I have something squared on the left equals a constant on the right, so I can square root both sides. That's going to leave me with x plus 9 over 2 equals, I have no idea what the square root of 85 is, 9 point something, but I know that the square root of 4 is 2. I also know that this exact same expression would be the same if I had a negative sign on the other side. Now all that's left is to add 9 over 2 to both sides. So since nothing is really going to simplify, we could actually just write this as negative 9 over 2 plus or minus the square root of 85 over 2. You could also have it written separately with a comma separating both terms. All right, our very last problem. My hint to you is to divide everything by negative 3 first. So I'm going to go ahead and do that. So if I divide every individual term by negative 3, which I can do because this is an equal sign, and as long as I do it to every individual piece, I'm allowed to do that. I'm left with x squared minus 4x plus 5. Now this problem really doesn't look so bad. I'm going to move my 5 to the other side, so I'm going to subtract 5 on both sides. And now I need to figure out what value I need to add on both sides so that I have a perfect square on the left. So I'm looking at b is equal to negative 4. I'm going to take half of negative 4 and square it. Half of negative 4 is negative 2, so inside I'm going to have x minus 2 squared. Negative 2 squared is positive 4, so I'm going to add 4, and I'm going to add 4. And if I add negative 5 plus 4 on the right, I get negative 1. So now I have something squared equals a constant, so I'm going to square root both sides. And now we have an issue. We're trying to take the square root of negative 1. And I will tell you that there is a way to do that, and it is not an Algebra 1 way to do that. It is something called imaginary numbers, and you're going to get to it in future classes. But with distance learning and just not having time, all we're going to ask is that if you ever get to a place where you are taking the square root of a negative number, you're going to stop right there, and you're going to say NRS, or you can use empty set brackets. This is no real solution. And that's where you're going to end. So just a quick recap. The very first thing you're going to do the very first step you're making on each of these problems is moving the constant. Sometimes you're going to need to do that, and sometimes you're not going to need to do that. The second thing you're going to need to do is to figure out what number you're going to add to both sides of the equation, taking half of b and squaring it. The third thing you're going to do is you're going to factor that new perfect square trinomial that you have on the left. Then you're going to solve using the square root method, just like you learned last class or last time. Don't forget about your plus minus, that there could be a positive and a negative value. I hope this video helped. Make sure you stop by office hours if you need a little bit more support. And check out that video online if you need to watch that. Thanks.